for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our second lesson on derivatives of combinations and compositions of functions. In the last lesson, we learned the sum and difference rules for derivatives. We also learned to differentiate a quadratic equation. Today, we will study the theorems on the differentiation of the product and quotient of two functions. If you are ready, we will begin. If f and g are differentiable functions at x naught, then the product fg is differentiable at x naught, and its derivative is given as f times g prime of x naught equals f prime of x naught times g of x naught plus g prime of x naught times f of x naught. This is called the product rule. We can apply this rule to find the derivative of the product of differentiable functions. For example, let f of x equal the cube root of x times the logarithm of x to the base 3. Can you find the derivative of this function? Working with a partner, try your best to do this now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back. I hope that you worked well with your partner. Let us look at each step that will lead us to our answer. F prime of x equals the derivative of the cube root of x times the logarithm of x to the base 3. This equals the derivative of the cube root of x times the logarithm of x to base 3 plus the cube root of x times the derivative of the logarithm of x to base 3. Written another way, this is 1 over 3 times x to the power of negative 2 over 3 times the logarithm of x to the base 3 plus the cube root of x times 1 over x times the natural logarithm of 3. Simplified, this is the logarithm of x to the base 3 over 3x to the power of 2 over 3 plus x to the power of negative 2 over 3 over the natural logarithm of 3. This equals the logarithm of x to the base 3 over 3x to the power of 2 over 3 plus 1 over x to the power of 2 over 3 times the natural logarithm of 3. Have you followed each step, students? If you have, you know that we must find the common denominator between both terms in order to add them. When we have done this, we find our answer. The natural logarithm of 3 times the logarithm of x to the base 3 plus 3 over 3x to the power of 2 over 3 times the natural logarithm of 3. Did you get the same answer? If you did, great work. We can also use the product rule to find the derivatives of the products of 3 or more functions. For example, let us find the derivative of this function that is composed of several functions. F prime of x equals the derivative of the product of the terms. So, it is equal to the natural logarithm of x times sine x times the derivative of x squared plus 1 plus x squared plus 1 times the derivative of the natural logarithm of x times sine x. Finding the derivative of each individual term according to our theorems, the expression becomes the natural logarithm of x times sine x times 2x plus x squared plus 1 times 1 over x times sine x plus the natural logarithm of x times cosine x. Finally, we may simplify into the form you see here. Be sure to practice applying the product rule after the lesson, students. It requires a great deal of practice. Now, let us learn how to find the derivative of a quotient of functions. This is called the quotient rule. If f and g are differentiable functions and g of x does not equal 0, then f over g is differentiable for all x at which f and g are differentiable. F over g prime of x equals g of x times f prime of x minus f of x times g prime of x over g of x squared. Make sure to note that if y equals f over g of x, then we use this notation to express the same relationship. Let us apply the quotient rule in an example. We will find the derivative of this function at x equals 1. F prime of x equals the derivative of x plus 3 minus x times x plus 3 prime over x plus 3 the whole squared. This example is simpler than it may initially appear, since the derivatives of both x and x plus 3 are equal to 1. So the expression becomes x plus 3 minus x over x plus 3 squared. Simplified, it is written 3 over x plus 3 squared. When x equals 1, the answer becomes clear. 3 over 1 plus 3 squared, or 3 over 16. You see, students, this is how we can apply the quotient rule to find the derivative of the quotient of two functions. It is time for our second activity. Find the derivatives of both of these quotients. Do your best, and I'll be back in 5 minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. Have you finished? Let us answer the first question together. F prime of x equals the derivative of x cubed minus 3 over x cubed minus 3 the whole squared. Therefore, the answer is negative 3x squared over x cubed minus 3 the whole squared. The second question is a bit more difficult. F prime of x equals the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over the denominator squared. This equals 10x minus 6 times x squared minus 3x plus 1 minus 2x minus 3 times 5x squared minus 6x plus 8 over x squared minus 3x plus 1 the whole squared. We then simplify the expression even further to a final answer of negative 3 times 3x squared plus 2x minus 6 over x squared minus 3x plus 1 the whole squared. I hope that you found the same answers. Remember, just like the product rule, we will need a lot of practice in applying the quotient rule. Today, we have learned how to find the derivatives of the products and quotients of two or more functions. Until next lesson, thank you, teacher. Thank you, students.